Before you work with inverse functions and their graphs, make sure that you understand previous work covered on functions. A function is a special kind of relationship between the x values in the domain and the y values in the range. Recall that a function relates each element of the domain with a unique element of the range. Functions can be one-to-one or many-to-one relations. We use a vertical line to test whether a graph represents a function or not. If a vertical line can be placed anywhere on the graph and it cuts the graph only once, then we know that the graph represents a function. This is called the vertical line test. For example, this is the graph of f of x equals x plus 3. If we move a vertical line across the graph, it's easy to see that for every x value, there's only one answer or corresponding y value. On this graph, there's only one x value for every y value, so it's called a one-to-one function. This is the graph of f of x equal to x squared. The vertical line test shows that this graph also represents a function. There are two x values for each y value except at the turning point. We call this a many-to-one function. Here are three more graphs that represent functions. At every point, a vertical line drawn through the graphs cuts each graph at only one point. Many of the graphs that you have worked with before, such as straight line graphs, parabolas, hyperbole, and exponential graphs, are all functions. Here is a graph that is not a function. The graph of a circle with the equation x squared plus y squared equals r squared. We know it is not a function because it does not pass the vertical line test. There are many points where the x value has two corresponding y values. An inverse function undoes or reverses the effect of another function. Now, note the following points. The inverse of a function may not itself be a function. If the inverse of a function is also a function, it is referred to as an inverse function. Only one-to-one functions will have unique inverses that are functions too. In the case of many-to-one function, the domain of the original function will need to be restricted in order to get an inverse that is a function. If the inverse is not a function, then its equation cannot be written in function notation. Here's one way to find the inverse of a function using its graph. You can reflect the graph about the line y equal to x to create the graph of its inverse. We can reflect on the graph of y equal to x minus 3 over the line y equal to x. The point -3 and 0 has been reflected onto the points 0 and -3. The points 0 and 3 has been reflected onto the points 3 and 0. The inverse of a one-to-one function is also a function. The inverse of a many-to-one function is not a function. If the domain of a many-to-one function is restricted, then the inverse can be a function. The convention of writing the inverse of a function f is f inverse of x. This is not the same as writing f of x to the power of -1, which is the reciprocal of f of x. In other words, 1 divided by f of x. Any function to the power of -1 is the reciprocal of a function.